This is lab 4.3, and we're going to be taking a look at the valence electrons and how that affects the group number. In the previous lecture, I had mentioned that the valence electrons helps to determine what group that it belongs in. So what you'll need for this is also your periodic table. So if you can have that out, and I'll be referring to that as well. So a couple of things before we begin this will be fairly fast as well, is I want to review what valence means. Valence means outer. So again, we're looking at the outer electrons, the electrons in the outermost shell. If we remember from lecture, we've been looking at three shells, shell 1, shell 2, and shell 3. And so I want to review the rules for that. Shell number one, or the first shell, can hold up to 2 electrons. Holds 2 electrons. It can't hold any more, so it can hold either 1 or 2. If there's 3, that third electron has to go into the next shell. Shell number 2 can actually hold 8 electrons. Okay, it can't hold any more. It can hold fewer. It can hold 1, 2, 3, 4, 5, 6, 7, 8, but it can't hold 9. Going to the third shell, and for the purpose of this class, we're going to be looking at the third shell, very similar to the second shell, and it can hold 8 electrons. Now, another piece of information that we need to know for this is because we're going to begin referring to our periodic table. We need to know, what does this number represent again? These numbers right here. H is number 1, helium is number 2. That again is the atomic number. So down below here, as a reminder, the atomic number has a couple of significant pieces of information. It tells us the number of protons, but it also tells us the number of electrons. So let's go ahead and I've abbreviated this periodic table to remove some of these transition metals because we're really only looking at these groups right here. You notice there's this space right here. Okay, we're looking at the first 1 period, 2 period, 3 period, and then the 4th period as well. Okay, so let's go ahead and take a look. Hydrogen. Hydrogen is element number 1. So I'd like you to put a 1 in the upper right-hand corner for that. Helium is element number 2. Lithium is element number 3, etc. Beryllium is 4. Boron is element number 5. Carbon is 6. Nitrogen is 7. Oxygen is 8. Fluorine is 9. Neon is 10. Sodium is 11, 12, etc. So we filled out just the atomic numbers, again, which is related to the number of protons and the number of electrons. So now what we're going to do is we're going to indicate how many shells that it has and how many electrons are in each shell. So if you remember, shell number 1 can hold 2. So what's going to happen here is that hydrogen with 1 electron, because it's element number 1, atomic number 1, that's the number of protons, but it's also the number of electrons. So hydrogen has 1 electron, and so therefore, it's just going to simply have 1 in its outer shell. Okay, how many can the first shell hold? The first shell holds up to 2 electrons. So that means helium has 2 electrons in its outer shell. Let's go into lithium. This is where it becomes a little bit more complex. So lithium has 3. It's element number 3, atomic number, number of protons, number of electrons. So it has 3 electrons. How many electrons will fit in the first shell? It can hold up to 2. So how many are left over now to fit in the second shell? There's only 1 left over, so it's going to be 1. Beryllium has 4. How many will be in the first shell? The first shell can hold 2. How many will be in the second shell? 2 plus 2 is 4. Notice how these are going to add to the atomic number because that's the number of electrons. The first shell holds 2. The second one is having 2 as well. It can hold up to 8. So going on the next one, we have 2 and in the first shell. How many in the second shell? 3. 2 in the first shell. How many in the second shell? 4. Again, note that it adds up to that right there. So there's going to be 2 and 5, 2 and 6, 2 and 7, then 2 and 8. So if there are any more electrons, they cannot fit in the first shell, they cannot fit in the second shell, they're going to have to go into the third shell. The third shell can also hold up to 8. So let's take a look at sodium. Sodium, how many will fit in the first shell? 2. 2 of the 11. How many will fit in the second shell? 8. 2 plus 8 is 10. I have 11 electrons total. How many will fit in the third shell? 8, but we only have 1 that is available. Number 12. We have 12 electrons to fill these electron shells. 2 will fit in the first. 8 will fit in the second. How many will fit in the third? 2 plus 8 is 10. How many more electrons do I have? 2. The pattern will continue. 2 plus 8 is 10 to fill the first 2 shells. How many to fill the third shell? 3. Again, 2, 8, and 4. 2, 8, 5. 2, 8, 6. 2, 8, 7. 2, 8, then 8. 8 is the maximum that can fit. 2, 8, and 8, 2, 8, and 8. We can't fit any more into the third shell. So what if we have 19? We're going to have 2, 8, and 8. 2 plus 8 is 10. 10 plus 8 is 18. How many will fit in the fourth shell, which we haven't talked about? 1. We have 20 electrons to fill the shells. 2 will fit into the first, 8 into the second, 8 into the third. 2 plus 8 is 10. 10 plus 8 is 18. How many will fit in the fourth shell? 2. Now again, this is why the periodic table is organized the way that it is. Take a look at this, which is your group 1. Notice how many electrons you have in the outer shell. Hydrogen has 1. Lithium has 2 in the first, it has 1 in the second. Sodium has 2 in the first, 8 in the second, 1 in the third. Potassium has 2 in the first, 8 in the second, 8 in the third, and 1 in the fourth. These are all group 1 because they all have 1 outer electron or 1 valence electron. How many does group 2 have? Group 2 has 2 in the outer shell here, 2 in the outer shell here, 2 in the outer shell here. Well, this is group 3. How many in its outer shells? 3 and 3. This is group 4. Hopefully you're seeing the pattern here. There's 4 outer electrons in group 4. This is group 5. There are 5 electrons in the valence shell or the outer shell of group 5. Group 6 has 6 electrons in its outer shell. Group 7 has 7 in its outer shell. In group 8, we have to ignore the helium. Sometimes this is called the group 0 in some books, but we're going to call it group 8 because most of them have, except for helium, have 8 in the outer shell. So what can we say? A general rule about the group number and the number of valence electrons. Big star right here. The group number tells you the number of valence, which is again your outer electrons. That's it for this activity.